So now we're going to continue our lab with a 2 5 mil extractions this time instead of one 10 mil extraction. So remember that we're using our separatory funnel and we have a separation based on density between the lower level, which is going to be methylene chloride, which has a density of about 1.33, versus water, which is going to have a density of about 1.0. So we will separate the two layers based on density, and based on density, we also know that the methylene chloride layer is the lower layer. All right, so let's do our calculations for doing the partition when I have two aliquots, 5 mils each, and then at the end we'll compare it to the answer that we got for our single 10 mil extraction. So the calculation for this one is a little more complicated because we're going to have two extractions this time. So we're still going to start off with our 40 milliliters of benzoic acid. That part will be the same. But now this time we're going to, instead of having 10 mils, we're going to be doing two 5 mil extractions. A will still be the total amount of benzoic acid we have, but now we're going to have two values of X. We're going to have X1 for the first 5 mils, and then we'll use X2 for the second extraction of 5 mils. Okay, so now we have two values, X1 and X2, which also means we're going to have two separate calculations, and let's go through those now. So our distribution partition coefficient formula is going to be a little more complicated, but let's start off with knowing that our partition coefficient, and in this case we know it's benzoic acid, and it still has the same value of 2 when it's extracted with methylene chloride. So, but this time we're going to have our numerator is going to be X1, which will be the amount of benzoic acid that goes into the organic layer for the first 5 milliliters. So we'll have 5 as our denominator. And then in the denominator, we're going to have A, which is our total benzoic acid, and then minus the amount that went into the organic layer in the first 5 milliliters, still divided by our total volume of 40. So let's simplify that. And so it's going to be similar to what we did before, and slightly different numbers. And we're also going to need to keep track of our X1. So let's simplify that. And we'll simplify that. So we have 4x1 equals A minus x1. And we'll take the x1 to the other side, and we'll get 5x1 equals A. And so let's simplify that. So we get x equals 1/5 A. So we can draw a conclusion that using the first extraction 20% of our sample will go in, 20% of our benzoic acid will go into the organic layer from the first extraction. So let's do this again. And we need to continue our calculation because now we have an x1 value. Now we need to repeat our calculation. And now we're going to use the symbols x2. And we have to have our denominator is going to be a little adjusted because some of our benzoic acid is gone. So our numerator is going to be x2, which will be the amount of benzoic acid that goes into the organic layer for the repeat extraction, over 5 milliliters. And then our denominator is going to be the total amount minus what went into the first extraction minus what's going to go into the second extraction, still over the total volume that we had to start off with, and that still equals 2. So let's go and modify our and simplify. Oops. And we can do another simplification here as well, because we know that x1 equals 1/5 A. Let's plug that in, and this whole component will then become 4/5 A, which will simplify that a lot. So we'll have 4/5 A minus x2 over 20 equals x2 over 5. And let's keep simplifying. We'll cross multiply. And then we'll distribute that 5. And then simplify a little bit more. So take our 5x2 to the other side. And I will get 25x2 equals 4a. And we can simplify that again. And we will get x equals, or sorry, x2, I should specify. So x2 equals 4 over 25a. And that's approximately 16%. So let's see what we get. So after our first extraction, we collected 20%. And after our second extraction, we collected 16% more, for a total of 36% of our sample was in the was extracted using 2 extractions. And so now let's compare that to the single extraction. And we said that it was 1/3, that x equals 1/3 A. So that gave us 33%. So The amount of effort it takes to do 2 5 mil extractions gains you about 3% of your sample. So for us, benzoic acid is relatively inexpensive, so that that financially doesn't have a big impact. But if you were talking about a very expensive component, that 3% can mean a significant amount of money. So we will be exploring, some students will be doing the single extraction, and some students will be doing the double extraction, and then we'll compare our data, and then we'll see for organic students if there really is a big difference between the single extraction and the double extraction. These videos should help you do your pre-lab, so let me know if you have any questions as you work through those.